Now we'll take a look at the general addition rule for probability. And again, it's associated with the word or. Now we're going to consider cases where two events are not mutually exclusive, meaning they do share outcomes. And you'll see here the rule starts the same way as before, but then there's this piece that will be subtracted. Now I just want to point out here that the probability that A and B, the probability of A and B, if the events were mutually exclusive, we talked last time about that value will be 0. So this general addition rule actually does work for any or question. So any or probability, we can apply this rule. It's just that this last piece is sometimes 0 when the events are mutually exclusive. So I'm just going to make that note here. So that component, if A and B are mutually, I'll abbreviate mutually exclusive, then that part, the probability of A and B happening, will be 0. So that piece will fall away if you have mutually exclusive events. All right, so let's consider, though, these events that are not mutually exclusive and see how this works. So a pet store surveys 12 customers regarding their pets, and the results include the following. 9 customers own a cat, 6 customers own a bird, and of these customers, 5 of those own both a cat and a bird, and we'll be picking one of the 12 customers at random, and we're interested in the probability that the customer owns a cat or a bird. So in other words, we'll be looking for all the cat owners along with all the bird owners. So union, or is union. Okay. So on my Venn diagram, I'm going to go ahead and indicate over here my N. So inside this rectangle, I've got 12 people, so 12 customers. And when they say that 9 customers own a cat, it means that inside that cat circle, I'm eventually here going to need 9 people. So I'm just going to make that one red. So there's going to be 9 people in that circle. And then 6 customers own a bird. So once I'm done building the Venn diagram, I know that that would be 6 people. And then there are actually, of those people, 5 are part of both groups. They own a cat as well as a bird. So I've got 5 people here in the intersection that own both. Okay. So just with that information, we can move forward using the addition rule. So the probability of cat or bird. So it starts like the last example. We would take the probability of the first event, the probability a person owns a cat, and include everybody that owns a bird. The problem with that is now if we just add those two together, 9 people own a cat, and that would be counting those 5 people. So that 9 includes the 5. And then if we added the bird people, 6 people, we would be including 5 again as part of that group. So if we added the 9 and the 6 together, that answer is going to be too big by 5 people, because 5 people would have been what we call double counted. We would have included them too many times by putting the 9 and the 6 together. So to get us down to the correct answer, we have to subtract anybody that was part of both groups, because they would have been counted twice so once in each of those totals. So we have to take away that number that's in the intersection. All right, so I'm going to continue getting the answer this way, but then we'll finish the Venn diagram and I can show you another way to get the answer. But I'd like to just use the given values to fill in the addition rule. So I know that for every one of those probabilities, the denominator is 12. So I just like to write it once. So we'll go piece by piece. So the probability of being a cat owner, there were 9 people, plus probability of being a bird owner, there were 6. And then we need to subtract the 5 people that were part of the 9 and part of the 6 so that we don't count 5 twice. And that's pretty much it. So we do total cat plus total bird and take away anybody that had both. So that's going to be 10 out of 12. Now, I can show you another way to think of this because this is union. So we are taking everybody, whether they're in one group or the other. We're combining the people that own cats with the people that own birds. So another way to get 10 is to finish the Venn diagram here. So if 9 people own a cat, and I've already got 5 people in the circle, then to fill out the circle, I'll just do a little math here. There's 9 total. Subtract the 5 people we already have accounted for. So I need 4 more people. So inside the cat circle, 5 people own a cat. They also own a bird. These 5 people do own both, but these own a cat. And so to get to 9, I need 4. So 4 people own a cat. They don't own a bird, but they own a cat. And then those 5 together, that's where we get 9. So I'm just going to write that at the bottom here. So the cat came from the fact that we would have 4 plus 5 to get 9. And then to finish the bird circle, I need a total of 6. So inside the green circle here, I need 6 total. I already have 5. So I just need 1 more person to get to 6. So 6 minus 5, we would need 1 more person. So I'm going to just write my bird here. So 5 plus 1 would give me 6. Okay. So this is why if I just add the 9 plus the 6, you'll see that in that total, the 5 people were included twice. And that again is why we subtract. And then let's talk about another way to see that the correct answer really is 10. So union, or is union. So union means take everybody, whether they're part of the cat owner group or they're part of the bird owner group. So instead of using the total plus the total minus the intersection, we could have finished this part of the Venn diagram and just said who's inside the circles. It's 4 plus 5 plus 1 is 10. So that is union and just involves the individual parts of the circles rather than the addition rule, which is the total of the circles minus the intersection. Okay, and essentially you can get answers in different ways. It doesn't make a difference. I will continue to use the addition rule because it's a formula that you can substitute and it always works. Now, my last note here, though, is I would like to finish my Venn diagram because 10 people are now accounted for that own a cat or a bird. I do have 12 customers total. So if 10 are inside the circles in the union, 12 people minus 10, I still have 2 people out here that are customers that don't own a cat. They also don't own a bird. So again, the outside numbers are totals. Those are not individual regions here. We can just double check now. If we just add the people represented in the Venn diagram, 2 plus 4 plus 5 plus 1 gives us the 12 people. All right. Long explanation there. So hopefully we're kind of getting the idea. Now we can just jump into another example and see how this works. All right, so 20 children are attending a summer camp. 15 signed up for archery, 12 signed up for basketball. Of these, 10 signed up for both archery and basketball. We'll pick a child at random and find the probability that they signed up for archery or basketball. So the main thing to remember as we continue throughout this chapter is you need to recognize that when you see or, it's the addition rule. So we'll learn other rules later, but or is always addition. And then you can just write the rule and substitute. So it's always the probability of the first event. So the probability they signed up for archery plus the probability they signed up for baseball. And then if there's anybody that did both, we're going to need to subtract that number to get us to the correct answer. All right. So even without the Venn diagram, I can just use this given information and say we have 20 people. If I take everybody that signed up for archery, there were 15 people plus, so union plus, I'll take everybody that signed up for basketball, and that's 12. If anybody signed up for both, I'm going to need to subtract that number because it would have been part of each of these groups. And there were 10 that signed up for both. So we subtract by the intersection. Okay. And I think that is 17 over 20. And again, I'm just leaving things as fractions, knowing that you can always do decimal or percent. We're just kind of going through with the fraction to keep moving. Now I do want to go ahead and fill in the Venn diagram. So outside here, so I know I have 20 people. And I know that the total archery circle, so total archery was 15 in that circle. And then the basketball circle, we had 12 people. So I need 12 people in that circle. And I know that there were 10 children that were in both of those circles, both of those events. So again, if I just want to finish the Venn diagram, in my archery circle, I have 10. I need 15. So 15 minus 10 would leave me another 5 people to fill out archery circle. And then basketball is 12. I already have 10, so I'm going to need 2 more. So this is another way to think of union. So if you take everybody inside these 2 circles, 5 plus 10 plus 2 is also 17. So that's union. So 2 different kind of approaches to it. And again, I'm just going to continue to use the addition rule, which says take the total plus the total and subtract the intersection. And then that always gives you the correct answer. All right. Let's do one that's given in table form, and we'll do a couple here. So this is a fitness studio where they kept track of whether or not customers that day were a new or returning customer, and then also what class they took that day. So I'm going to do a little bit of totaling here. So of the people they kept track of, yoga, that looks like 40 people went to a yoga class. 20 people went to a dance class, 10 people took boxing, 30 people took Pilates. And if I go across and add up all those people, that should be 100. So they kept track of 100 people that day. And of those 100 people, they also kept track of who was new. So if we go across and add there, that will be 36 new customers. And then returning customers, there were 64. So again, giving us our 100 people. So this is called a two-way table. We're keeping track of 2 things, new returning and also what class they took. All right, so we're going to pick a customer at random and find the probability that they either took dance or boxing. So we'll just do D and B, dance or boxing. Now notice here that the people that took dance and the people that took boxing are 2 mutually exclusive groups. So nobody went to both groups. These 20 people went to dance. I'm sorry, nobody went to both classes. They kept track of where people went. 20 went to dance, 10 went to boxing. So mutually exclusive events. So it's the probability they went to dance plus the probability they went to boxing. We could still write subtract, but there won't be anything to subtract because nobody did both. So that's why the rule is simpler when we don't have an overlap. We don't have an intersection. So we can just go right to adding the 2 groups. So out of 100 people, 20 took dance plus 10 took boxing. So 30 over 100 would be our probability. Okay, and then we'll take a look at the probability they were new or they took boxing. So I'm going to do some circling here just so you can see it's very similar to a Venn diagram. So if I circle all the people that were new, I'll just do them in red. So these were my new people. That's where that 36 total came from. And then if I circle the boxing people, so we'll be doing or, and we know we'll be looking at those two groups and combining those two groups to count how many people were part of one or the other. So the numbers on the outsides of the table, the column sum and the row sum, are like the totals on the outside of a Venn diagram. So the totals of the two events. And then you can see the intersection right there. So two people were new, and those two people were not only new, they also met the criteria of being somebody that went to boxing. So the intersection, the overlap there up here is similar to that overlap there. So the formula is still the same. It's the addition rule. And eventually I sort of stopped writing this rule. We've done it several times. So I won't require you to always write this rule. If writing it helps you, write it. But if you can just go right to the substitution, that's fine too. So I would take everybody new plus everybody that went to boxing and make sure I subtract anybody that was part of both groups. So that is your addition rule, the general addition rule that will always work. So generally, what I do in my head, I think denominator first, 100. And then I just say, I'm going to, sorry about that. I'm going to say, let me take everybody that was new, 36, plus everybody that went to boxing, 10. So I call it total there, total there. So the total plus the total. And then I always subtract anybody that was part of both groups. And that was the two people there that were in the intersection. So I say total, total minus both. Total, total minus people that were part of both. All right. And that, I believe, is 44 over 100. Okay, one more. And for this one, there's no table or Venn diagram shown. I'm actually going to make a table, which can be helpful, and it'll be up to you. But here's the deal. We got Bill the Boring, and in his dryer, he's got 14 blue dress shirts, 10 gray dress shirts, 6 blue t-shirts, 7 gray t-shirts. He is going to take out a piece of clothing at random to see if his clothes are completely dry. All right, so I'm going to use the addition rule to find the probability that the piece of clothing he takes out is blue or is a dress shirt. Okay, so or, again, probability. Or is the addition rule. So blue or a dress shirt. All right, so rather than me writing the rule again, you can write it if you would like, but I'm just going to go right to the substitutions, and I'm going to organize the data in a table because I think for some people that's helpful. It's not necessary exactly, but it can help to sort of see how it relates to what we've been doing. So there's two things to keep track of here. Some of his shirts are blue and some are gray. So some are blue, some are gray. And some of his shirts are dress shirts. Sorry, my line's not very straight, but some of his shirts are dress shirts and some of his shirts are t-shirts. And then I'll just fill in the table. So 14 blue dress shirts, 10 gray dress shirts, 6 blue t-shirts, and 7 gray t-shirts. And then I can do some totals here to see what's going on in his dryer. He's got 24 dress shirts. So just totaling here, 24 dress shirts, 13 t-shirts. So if I add those together, that'll be 37 pieces of clothing. But then he also categorizes them by color. So he's got 20 blue and 17 gray shirts. All right. So I'm going to do or using that language I spoke about before. So I know that I'd be taking the total number of blue. And so I'm just going to highlight on my table here. I'd be taking all the blue plus all the dress shirts, and I would be subtracting any shirts that were part of both of those groups. And that would be those 14 shirts that are blue, and they're also dress shirts. And if it helps to sort of circle here, those are the blue, those are the dress shirts. So I can see that 14 shirts were a part of both groups. All right, so again, rather than writing the whole rule out, which you can if it helps, I'm just going to go through that process. I take all the blue ones, plus, or is plus, I take all the dress shirts, and then I make sure to subtract any shirts that were part of both of those groups. All right, and that should be 30 over 37. All right, and that ends the addition rule, the or rule for probability.